Good day and welcome to today's lecture. In my last lecture, we were able to look at Schrodinger and Paul Dirac equation and solution to those equations. The solution gave rise to four quantum numbers. The four quantum numbers, one determines the energy, the second one determines the geometrical shape. These quantum numbers are one, the principal quantum number which determines the energy level that the electrons occupy. These are represented by n. It can be 1, 2, 3, and so on and so forth. The second one is the subsidiary. You call it subsidiary. You can also call it azimuthal or Sommerfeld quantum number. It describes the geometrical shape occupied by an electron, and it is represented by a letter small l. It ranges from 0 up to n minus 1. If n is equals to 1, it will be n 1 minus 1, which is 0. When n, the energy level, when it is 2, it will be 2 minus 1. It will give us an L value of 1. Then we now move on to the magnetic quantum number. This describes this spatial orientation of an atomic orbital, and its value ranges from -1 to +1, with a total value of 2L, 2 small l, plus 1. Let us look at it in this format. If L, that is the azimuthal quantum number, if L is equals to 0, it will be 2 times 0, which is 0, plus 1. It will give us a solution of 1, and that 1 is equivalent to S, which is L. When L is equals to 0, it will be 2 times 0, which is 0, plus 1. The solution is 1. And when L, that is the subsidiary quantum number, is 1, it will be 2 times 1 plus 1. It will give us 3. That is the P, with the value of P. We have the px value, the py, and when you look at the Cartesian orientation, the px, x, y, and z. That's the Cartesian orientation. We have 3 types of p. When L is equals to 2, when the azimuthal quantum number is equals to 2, the magnetic quantum number, it will be 2 times 2, which is 4, plus 1, which is 5. It gives us a 5, and it is represented by D, which are dxy, dyz, dxz, dzx, dx square minus y, and dz square. When L is equals to 3, when n is equals to 3, it will be 2 times 3 plus 1, which is 7. And this was give us the F sub shell, the F sub shell. And the next one, like we said earlier, the solution gives us the principal quantum number, the subsidiary, the magnetic, and the fourth one is the spin quantum number. The spin quantum number gives us either the clockwise or the anti-clockwise orientation of the electron, the clockwise or the anti-clockwise orientation of the electrons, Now, these are all efforts by so many scientists, Schrodinger, Dirac, trying to describe the electron in an orbital. And the next thing is we are going to look at the rules governing filling of an electron. That is, if you want to write the electronic configuration, how do you write it? You have to look at the shell. We have about how many orbitals here? We have about 4 types of orbital. We have the s orbital, we have the p orbital, we have the d orbital, and we have the f orbital. We have 1 type of s orbital. We have 3 types of d orbital, the px, the py, and the pz. And we have 5 different types of d orbital, and we have 7 types of f sub shell. And each one of them can accommodate the maximum of 2 electrons. If S can accommodate the maximum of 2 electrons, the S orbital here will accommodate, it only has 1, it can accommodate maximum of 2. Here, if the px accommodates 2, the py accommodates 2 with different orientation, the pz accommodates 2, then we will say that the p orbital can accommodate the maximum of 2 times 3, which is 6. In this same case here, the d orbital can accommodate 2 times 5, which is 10, maximum of 10. And the f orbital can accommodate the maximum of 2 times 7, which is 14. Now we are going to look at the rules governing filling of an electron in an orbital. A lot of people have worked towards this in this direction. One of them is AFBAO. The second one is Pauli exclusion principle. The third one is Horn's rule. They will guide us on how we are going to enter these electrons respectively into their respective orbital. Thank you for listening. In our next lecture, by the grace of God, we are going to take these things and the rule so that it will guide us in filling our orbital. Thanks for listening.